In this video, we're going to talk about how to find a slope and an equation for a tangent line on a specific point on a curve. So if you recall in algebra, we always use this rise over run formula to find our slope, and then we plug that in and get a linear line. And then if we look at this example curve here, typically for that to work, we'd have 2 points on this curve, and then we'd have our linear line going through those 2 points. Now what this would give us would be an average rate of change between these 2 points. So it wouldn't be like an accurate representation of a specific point on the curve. So what the tangent line allows us to do is to get a line that specifically runs through just one point on the curve. So it gives us an instant value. So in this video, we're going to go ahead and use these two formulas here. So this formula gives us the slope, and then we're going to use our classic point intercept form formula here to find our final equation. So for our first example, we'll just go over finding the slope first. So we have a function of x, and it's just going to be radical of x. And then we'll have a limit value of 2, or excuse me, 4. So using this formula here, we can plug in our function for this value here, and then the value that we get when we plug in our limit value inside our function, and then x minus our a value. So we'll go ahead and just start writing the formula out. So we have a limit of x to 4. Then our function is going to be the square root of x minus this value plugged into our function, which gives us 2 over x minus 4. Now, looking at this, obviously we can't plug in 4 into this because we'll get 0 over 0, and then it's not defined. So we'll go ahead and get the conjugate of this. So we'll multiply both the numerator and the denominator by radical x plus 2. And then we end up getting x minus 4 over x minus 4 times this value here. Then these cancel, and then we have 1 over radical x plus 2. And then once we plug our a value in, we end up with 1 over 4. So that's our slope. Now in order to actually use this slope formula to find an equation of the tangent line, we need to have a specific point. So for our next example, we'll have a specific point in the curve where we can go through the whole thing. So let's say we have a function x is equal to 3x squared minus 5 at point 2, 7. Now for this formula here, our a value, we typically always use the x value. So our slope is going to be equal to the limit x to 2. And then we'll just start plugging into our formula. So first we just write our function. In this case it's 3x squared minus 5. And then we subtract it with plugging this 2 value into our function. So 2 squared is 4 times 12, or times 3 is equal to 12, and then minus 5 is equal to 7. So we subtract 7 all over x minus 2. Okay, and then we can go ahead and reduce the numerator down further by subtracting that 7 value. So we'll get 3x squared minus 12 over x minus 2. And then we can go ahead and factor a 3 out. So be 3x squared minus 4 over x minus 2. And then we can break this down even further. So 3x minus 2, x plus 2. So as you see, if we plug in 2 here, we get a 0 over 0, so that doesn't work. So we'll go ahead and cancel these values out. We'll have 3 times x plus 2. And then we can go ahead and plug in this one value, and then we'll have 3 times 2 plus 2. And that gives us 12. So our slope is equal to 12. Now that we have an x and a y point, we can use our point slope formula here and just start plugging in. So we have y minus our y1 value, which is 7. It's equal to our slope 12 times x minus our x1 value, which is 2. Then we distribute these and then add 7 to the other side. We'll get y equals 12x minus 24 plus 7, and a final answer of y equals 12x minus 17. So here's our equation of the tangent line, and here's our slope. Do one more quick example. So in this one we'll have a function is equal to 4x minus 3x squared at point 2, negative 4. So let's find our slope first. Like I said, we use our x value for our a value in the formula here. Go ahead and plug our function in for here. And then if we plug our 2 back into this original function, we get 8 minus 12. So we'll just go ahead and write those both out. So 8 minus 12. over x minus 2. And then we go ahead and just start breaking this down. So we'll have a, and I'm going to rearrange it too, just to make it a little bit cleaner. So I'll start off with the negative 3x squared plus 4x. And then we have a negative 4, but we also have this negative sign here. So that's plus 4 all over x minus 2. Now just looking at this limit here, using our basic algebraic rules that we discussed in another video, I want to get rid of this x minus 2. But if I were to factor this out, I'd have to use an x plus 4. So we're going to go ahead and factor a negative 1 out. So what that ends up giving us, so we'll start off with a negative sign out here. And then we can do 3x plus 2 times x minus 2 all over x minus 2. So now we can get rid of these. And then we'll have a negative 3x minus 2. And then we can just plug in our limit value here. So we end up with a negative 8. So now we have our slope. We can go ahead and use our point slope formula with our point here. So we have y minus negative 4 is equal to negative 8 times x minus 2. Gives us a y plus 4 equals negative 8x. After we distribute this, we get a positive 16. And then we just add the 4 to the other side, or excuse me, subtract the 4 the other side, and we end up getting with the equation of y equals negative 8x plus 12. So that's it. So if you're given asked to find, either slope or equation for a tangent line to a curve using a limit, typically you're just gonna want to use this equation, and then it's pretty straightforward. Once you find your slope, then just use our classic point slope formula from algebra.